Okay, hi all. In this class, we are going to see ventricular synchronous demand pacemaker. Okay, so ventricular synchronous demand pacemaker in the sense, see the name, the title of the pacemaker. So here we are going to see ventricular, that is the QRS complex, and demand pacemaker in the sense whenever there is a need or demand, in that case only the pacemaker will get activated. In other cases it will remains off state. Okay, it will remains inactive, right? So the synchronous means, so the QRS is synchronized with pacemaker, that is the ventricular is synchronized with pacemaker, that means the QRS is synchronized with the pacemaker. So whenever there is a QRS, the demand pacemaker will get activated. Whenever there is no QRS, if you have any other ways, um, um, it remains off. Okay, that is the name of ventricular synchronous demand pacemaker. So this pacemaker is going to work based on the function of based on the occurrence of QRS. Okay, so let's see the block diagram of this type of pacemaker. You have the electrodes, because whatever type we need to sense, right? So after sensing only we get to know whether there is a need of pacemaker function or not. Okay, so for that sensing activity and also for giving the impulse, for sensing and also giving impulse. Okay, though for these two activity we need the help of electrodes, through which only all the things will happen. So first one is electrode. So here we are going to first sensing what is the actual heart rate, whether everything is within this threshold value. Okay, so first we are going to tap the ECG signal by means of electrode, then it goes to where then sorry wait then it goes to QRS band pass filter. So this QRS band pass filter is going to extract only QRS from ECG signal. In the electrode we will get all PQRS T waveform. So from that we are going to extract only the QRS. The reason is that here we are going to develop the device for ventricular synchronous demand pacemaker. That is, we are going to concentrate only the QRS, so that we have used QRS band pass filter. This band pass filter will extract only the QRS signal from the ECG. Then we have QRS amplifier. The reason is that whatever signal we are getting from our body, it's everything is weak signal, it's weak in amplitude, right? That we have to strengthen by means of amplifier. So there is the need of QRS amplifier. Then we have a threshold detector. The reason of the having of this threshold detector is that all the waves, okay, so either it is a noise or actual data, everything is found as a waveform. We don't know whether the taking waveform or the given waveform, whether the coming input is QRS or not. Okay, so for that we have some standard values of QRS to for any type of adults or small kids or something. Okay, so that threshold value we will be fixing here. This threshold detector, what it will do in the sense, it's going to compare the incoming QRS waveform with this threshold values. If it match, then it will consider thus the incoming consider that the incoming QRS is the actual incoming way is the actual QRS way, so it will let to pass to the next stage. Whereas the incoming waveform, it doesn't match with this threshold value, in the sense it may consider as some other noise or something, and it will not let to get past to the next stage. So that is the reason of having this threshold. So in this way you are going to allow only the QRS value in the whatever the values you are having, whatever waves you are having apart from QRS, like that may be because of noise or something, everything will get removed. Okay, at this stage. Then we are going to the refractive period. The reason of this refractive period is already we discussed. If the QRS is there, QRS complex is there, the anyway this pacemaker is going to be in on stage, but it has to give the impulse on that refractive period. Okay, so that it will not reflect the heart. Okay, the pacemaker is going to be on overall, overall function of the cardiac pacemaker or overall function of the heart. if it sends the normal QRS in the sense, it will fire the signal on the refractive period. So that is the reason you have added this refractive period. So it will wait for that refractive period. So if it is there, then it will give the impulse on refractive period. If it is not there, then it will you give the impulse after the refractive period. So then the impulse is being generated by free running oscillator T2. So this is the one type of oscillator. It will generate the signal whatever the value we have fixed, that value will be generated. This is going to be the pulse given by the cardiac pacemaker. So this from this cardiac pacemaker through the output driver circuit, by means of electrode we will be giving the pulse. Okay, so it will give the pulse. Anyway, if it is when if QRS is there, it will give at the exact refractive period. If it is not QRS, then it will give impulses at the end of QRS. Okay, so this is the overall block of what is ventricular synchronous demand pacemaker. Thank you.